talking about activity testing. And we saw that for activity testing, you have two main testing subclasses: activity instrument test case 2, activity unit test case 2, and then also for we have yet another one called single launch activity test case, which I'm going to talk about more today. Last time we saw an example of the use of activity instrumentation test case 2 in the little example that I showed you. And besides this, we have the activity unit test case, which has these properties, which I talked about last time. The third kind is called as the single launch activity test case. This test case is provides an environment where you can carry out multiple tests before you shut down the activity that you call. Basically, you do the setup and tear down before you call any of the lifecycle methods of an activity. Between setup and tear down, you can only call one method. You can issue only one method call in the other two examples, that is instrumentation test case and unit test case. The single launch activity test case, as the name implies, means that you will call the setup method of this particular test case class once, and then after that you can do multiple test cases, and then tear down can be called at the end. The only difference here is that you cannot inject mock objects. You saw how last time I talked about mock objects being supplied to an activity. These things are not possible, and also this is can be used for testing activities that runs in other than standard mode and so on. And as you see, between test cases, so notice that you call the setup only once and then the teardown only once instead of every time per method call. So this means that a bunch of tests can be run together without the environment of the activity being reset. Okay, multiple calls. So this is one way you can ensure that the activity can handle multiple calls correctly. Now, what are some of the things that you will test using these test cases? Obviously, an activity responds to inputs. So one of the things, for example, if you have an edit text view within your activity, you could input some value to the edit text widget, edit text view, and then check and see whether the value is being returned by the view to your activity correctly or not. Remember, the activity has a layout that you create using XML, for example, and it might have an edit text field, and then you would expect the user to input something into an edit text field, and obviously the value that is input by the user is claimed back by the activity by calling the activity. So you need to, this is something that you can check when the edit text field is being called. Is it returning the correct value that you supplied to the edit text field or not? You can verify whether a valid keystroke sequence is accepted, and will it enable the OK button. Remember that when you type a valid keystroke sequence, you want to ensure that the OK button is turned on. An example of this would be, suppose you create an edit text field that will take only numbers. Say, for example, you expect a user to input a phone number into a field box, and the user inputs alphabets. The OK button should not be turned on. If the user inputs numbers, and if the numbers have to be a certain number of digits, say, for example, a phone number in Hong Kong by default will contain 8 digits. All the phone numbers are 8 digits. If the user inputs 9 digits, it should not work. If the user inputs 7 digits, it should not work. If the user inputs anything other than numbers, it should not work. So these kind of tests can be carried out. If the user inputs invalid input, will your activity respond correctly to the input or not? That's one more test that you can carry out. Now, all these, obviously, you do carry out some of these things manually, I hope, when you're designing your app, right? I hope that you do. And indeed, when I test your examples, when you come for the demo, I might do some of these things manually myself to see whether your activity can handle these things correctly or not. Okay? In addition, of course, for the tests, you are trying to test the lifecycle events. Lifecycle events including all the method calls that are part of the lifecycle. So, for example, whether the activities handle the lifecycle events correctly. Lifecycle events are actions either from the system or the user. From the system, for example, the system will call the on pause, on stop, and other things, the on create, and so on. Callbacks could be triggered by, for example, clicking of a button, where the on click method would be called, and so on. Okay. Similarly, your activity may have to respond to pause and destroy events by saving state so that it can be restored if required later. This can be checked to make sure that your activity's certain states may be maintained by you specifically. Can you restore the activity back to its state when it was destroyed, if it gets destroyed by the system? All these things can be checked. One place where you have these things, this kind of events occurring is a change in the screen orientation, whether by design or accidentally the change. If that happens, you have to ensure that the state is preserved appropriately when the screen orientation is changed, and the activity is restored to the correct state. So all these can easily be tested using the test cases. Intents. Suppose your activity is specified to handle different kinds of intents. Normally, if your activity can only be called by an explicit intent, then you have to specify the activity by class name. But many times you may create activities that are called by implicit intents. How do you enable this? You do this by specifying the intent filter in the manifest. So one thing that you can test is if you are creating activities that are supporting different kinds of invocations by specifying the intent filter, you can check and see whether your activity gets triggered by any one of those intents that it is supposed to handle. So these things can easily be done. Now again, the activity instrumentation test case 2 allows you to send mock intents. So if you have specified different kinds of cases in the intent filter, you can check for each one of those and see whether your activity gets invoked when such intents are sent, different kinds of intents are sent or not. Okay? Runtime configuration changes. You remember we have runtime configuration changes, things like, for example, change of the availability of internet access, or turning off internet access by the user, change in the language, default language being used by the application. Many such things can easily cause a change in the environment within which your application is running. Does your application handle it correctly or not? Say, for example, the user invoked your application, and at that point, internet access was turned on and the application is working fine. But if your application depends on access to the internet, if the user, for example, walks into a closet or some dead zone where no signal is being received, what will your activity do? What will your application do? Will it crash, or will it identify saying internet connection lost, so some of those things that you can do with your app is no longer feasible? These things can easily be checked for. Similarly, things like screen sizes and resolutions. With Android, this is one of the headaches. Well, headaches at the same time, depending on how you view it. Android runs on different kinds of devices with different screen sizes, different configurations, and so on. Obviously, walk into any Fortress or Broadway or any other mobile phone store, you would see rows and rows of Android devices of different sizes. You have Sony Xperia of this size, this size, this size, and then you have the latest Galaxy S3 with 4.7-inch screens, and then HTC, what is the new one? HTC something coming out with a 4.7-inch screen, and then at the same time you have those cheap Android phones with like 2.5-inch screens. Your app should be able to run on any one of them without problem, automatically adapting to different screen sizes. Not only that, different screen resolutions also. Will your application automatically adjust? Remember that if you design your application correctly, you should have specified different kinds of resources for different screen densities. Like you have a HDPI, LDPI, MDPI, XHDPI, and so on, and landscape, portrait mode, and so on. So if you have specified your resources correctly, it should be, your application should automatically adapt to the different screen sizes appropriately. You can carry out many of these tests. Even if you don't have those devices, you can still create multiple emulators with different screen sizes and carry out tests on multiple emulators. That's the first place where you can test. Obviously, you don't need to buy 10 different phones or 10 different screen densities just for the sake of carrying out tests. If you're rich, yes, you can, but otherwise, at least use the built-in emulators to configure them with different sizes and then test and see if it runs correctly. Now, how do you test the user interface? Now, the user interface obviously is controlled by this main thread called as the UI thread or the main thread. Okay, so any access to the user interface related things has to be done through the UI thread. If you try to access it from outside the UI thread, Android will complain, right? And it'll cause a crash, right? So with any of the instrumentation-based classes, that is Android test, instrumentation test case 2, and so on, you can invoke methods against the UI of the application and tests. The other test cases, like the unit test and the single launch test, they don't allow you to do this in practice. If you need to run the entire test on the UI thread, you can specify by annotating a thread with this. If you do this, then this will result in running all the method statements on the UI thread. If you put this annotation for your methods. If methods that do not interact with the UI, they should not be allowed. So, for example, you cannot do things like these things on the UI thread. If you want to run now, why should you not do this? This will result in a idle wait, and you should never be doing that on the main UI thread. If you do that, Android will complain. Okay? So, to run a subset of test methods, for example, on the UI thread, you create an anonymous class of type runnable. Runnable is the type for creating a thread. You put the statements into the run method, instantiate a new instance of the class as a parameter for the method app activity run on UI thread. Okay, like this, for example. So this, obviously, when you saw the test case, you saw how you can get in a handle to the activity, and then you specify it this way. If you specify it this way, all these will be run on the UI thread, and that will allow you to carry out tests on the user interface. Okay. Similarly, you might generate key events on your device if your device can handle physical keys. Then you have to turn off the touch mode and then make use of the emulator with the non-touch mode. This can be easily done by turning off touch mode. Because if you are in touch mode, any key events are ignored. Key events will not be accepted. So to turn off touch mode, you can invoke this one before you call the get activity to start that. So this way, you will be allowing the activity to accept keystrokes generated by the different keys within your application. If your emulator or device is locked, how do you unlock it? So for example, UI tests will not work on the emulator or the home if the home screen is disabled with the key guard pattern, right? Many of you have seen that if on your device it gets locked after a period of time, you want to unlock it so that you can allow things to run on the screen. The locking is there for a reason, because it allows your device to be put in your pocket without being disturbed by unnecessary handling of the device. Okay. Now, so in this case, you can disable the key guard for the home screen of your device, and you can explicitly disable the key guard in the manifest file. So that way, once you start off this particular application test, the screen will not get locked while you're carrying out the tests and so on. So this is how you would disable the key guard and so on. Key guard is mainly used for making sure that if the device is inactive, any touches on the keys will not cause your device to do unnecessary or inappropriate things. But when you're carrying out tests, obviously you want your system to respond to key events being sent to it automatically. As you will see later, we'll see a couple of tools that enable us to send key events and so on to your emulator directly from code to be able to test different things. Now, when you're carrying out UI tests, suppose Eclipse in the Logcat complains something like this. What exactly is going on? It says wrong thread exception. If this occurs, the failure trace contains a statement, something like this there, then that means that probable cause is that you tried to send UI events to the UI thread from outside the UI thread. This is not acceptable for Android. The UI events have to be sent directly on the UI thread. Remember when we talked about async task, we mentioned that if you need to post something to the main UI thread, you have a method of doing it either by declaring a handler, or in async task you have a method of executing something on the main UI thread and so on. So these things could be the reason why you might see a problem like this. You might see messages like this, Java runtime exception. So if this kind of thing occurs, this is basically telling you that this method cannot be called from the main UI thread. So this might be the case where you call a method that should not be executed on the UI thread from the UI thread. If that happens, maybe you can remove this annotation on your method so that it can be executed correctly and so on. So possible reasons why you might see problems with testing. Service testing is again similar to activity testing. Activities and services have some similarities. Both of them have life cycles, and both of them do access objects. So you should, for service testing, you need to provide a framework for service objects and provide mark objects to them and so on. So for this, you have this class available to you called as the service test class. Okay, so you can, using this, you can test a service without using instrumentation also. So when you design a service, you have to consider how you're going to test and examine the various states in the lifecycle of the thread. So if the lifecycle methods start up your service, such as on create, on start command, do not set a global variable whether to indicate they are successful. You may want to provide such variable for test cases, just to make sure that the test case class is informed about the fact that such methods worked correctly, and so on. Okay, so these things can be carried out by using the service test case class. This is the one that supports carrying out tests on the service. So, for example, this service test case class extends the JUnit test case. We talked about the JUnit test case in the previous class, and this is what allows you to execute the service test cases. This service test case allows you to supply mock application and context objects to your service so that you can test the service in isolation. Okay, and the test environment will be initialized at the moment you call this particular method or these. Remember, these are the ways that you start the service, either by saying start service. If it is a bound service, then the moment you call bind service, if the service is not already running, then it will start up at the point. Okay, so again, the structure of the service test case has similarities with the activity instrumentation test case that you have seen earlier. You have methods for setting up the system before you issue the test cases or call the services lifecycle methods and so on. Okay, and also you can supply mock objects to the service. Sometimes services access objects. Say, for example, you design a service that is going to access a content provider that is part of your device. Then you should be able to supply a mock content provider to your service so that it can be tested appropriately, and so on. So these kind of things can easily be taken care of from a service. Okay, so service testing. Now let's look at content provider. So in Android, you see that content providers are a method of encapsulating data and then supplying the data to other applications. So this is usually enabled by providing data APIs to the content provider through which other applications or other activities can invoke a content provider and then seek the data from it. So content provider may have public constants, and usually content provider has few public methods, and these are not standardized methods because content providers are created by the user based upon the user's need and so on. So when you create test cases for content providers, you have to look at the specific content provider, the API that the content provider provides, and then design the test cases appropriately. And this can be supported by using something called the provider test case too. So this allows you to carry out content provider tests in an isolated environment, including things like supplying mock content resolvers, mock isolated context to your content provider. So if you want to carry out tests of content provider in isolation, that is allowed to be done by using this. Okay, so the provider test case 2 again has similarities to instrumentation test case 2 that you have seen earlier, and this extends the Android test case similar to the JUnit test case and so on. And so this allows you to do things like creating isolated context objects, mock context resolvers. Remember that content providers are invoked by using context resolvers. So these are supported by the provider test case too. Okay. Again, for a public provider as a contract, for example, testing with constants that your provider publicly exposes, testing all the URIs offered by your provider. Providers expose their content through URIs, uniform resource indicators, which you use within your application. We saw this when we used content providers earlier. You can test the business logic of your content provider, and so on. So all these things can be carried out. All these test cases can be carried out on your content provider. Okay. In addition, Android has these two tools called as the Exerciser Monkey, UI Application Exerciser Monkey, and then there is another one called Monkey Runner, two different monkeys that we talked about. What is this UI Application Exerciser Monkey? This runs on your emulator or on a real device on which you want to carry out tests. What does this Exerciser Monkey do? It generates a pseudo-random stream of user events, such as clicks, touches, and gestures. This is what allows you to carry out user interface testing. How do you test a user interface of your application? You cause random things on the screen. Now, of course, if you're a human being, you know what to touch and so on. But if you want to be able to test your application to see whether it can withstand random touches on the screen by people that don't know exactly how to use the application, then the UI Application Exerciser Monkey enables you to do that. So if your user interface has got several different widgets that are actionable, then the UI Application Exerciser Monkey will randomly generate events. Say, for example, it will generate an event to touch it, equivalent to touching a button, touching a view on the screen, clicking of a button, long key presses. All these kind of things can be done from the screen. Now, this is a command line tool. You can invoke it by using this particular syntax, and this will enable the monkey runner, the Exerciser Monkey to generate different UI events. ADP is a very useful package, which I'll talk about in a minute. Very useful tool, which I'll talk about in a short bit. Okay, so for the Exerciser Monkey, you can set up things like number of events to attempt, operational constraints, like restricting to test a single package. As you can see, you can specify saying, send all these events to a specific package of your application, and so on. Okay, and several different kinds of settings that the Exerciser Monkey allows you to basically carry out different kinds of UI tests. So if you're designing an application and you want to carry out random tests of the user interface, use the Exerciser Monkey to generate random events and see if your application will work correctly. If it keeps crashing, then that means that there is something that you should go back and fix within your application. Another tool that is available for you is called as Monkey Runner. What does a Monkey Runner do? This Monkey Runner is different from the UI Exerciser Monkey. UI Exerciser Monkey is primarily used for user interface testing. The Monkey Runner is used for carrying out a whole bunch of tests in a very controlled manner. So, for example, this Monkey Runner tool enables you to control devices and emulators from a workstation by sending specific commands and events from an API. So, for example, if you want to carry out the test of your application on 5 different emulators of different screen sizes, you want to be able to control them by by causing different kinds of events and seeing what happens. You can use this Monkey Runner in order to do this. Okay. Now, Monkey Runner uses a Python program syntax for an app. For example, Monkey Runner allows you to install an app on an emulator, carry out a bunch of tests, sending keystrokes to it, take screenshots of the UI to see what your application is doing, and so on. Different levels of testing can be carried out at the functional level, framework level, and so on. As an example, the syntax would look something like this. Okay, so what does Monkey Runner allow you to do? It allows you to control multiple devices so that you can carry out tests on multiple level of devices. It allows you to do functional testing, automated start to finish of an application. Regression testing, we talked about regression testing briefly last time. If you have taken a software engineering course, you know what regression testing is all about. It's about carrying out prior existing tests on a newer version of your application. And the monkey runner allows you to do extensive automation because the monkey runner accepts scripts which are written in a language called Python, which is a Java supported version of Python language. And this is what you use to generate a bunch of scripts and then allow the monkey runner to automatically execute these scripts on various devices. This is an example of a monkey runner script. So as you can see, we're specifying, for example, monkey runner modules to run, and then specifying the device, and then installing the particular application on the device, then carrying out different tests on the application. So again, you see fairly straightforward syntax being used by the monkey runner example. So you can send keystrokes to see if the device does things correctly. You can take a screenshot of the device and then write it into a file, store the screenshots into a file, and so on. So what does this allow you to do? It allows you to carry out automated testing of your applications, multiple automated testing for applications. So the API is contained in 3 modules, which is part of the COM.Android with Monkey Runner. Monkey Runner itself is utility methods that the Monkey Runner program provides. Monkey device represents the device or emulator on which you are carrying out test, and monkey image is the screen capture that your monkey runner generates. So this is a quick overview of different kinds of testings that you can carry out on your Android device. All right. The last topic that we will deal with in this course is debugging techniques and tools. Obviously, as you are going through the process of implementing your applications, implementing your examples, and so on, you might encounter situations where you want to trace what your application is doing under different circumstances. Debuggers are very, very useful for this purpose. How many of you use debuggers when you write code? How many of you know how to do breakpoints and so on in the code? Okay, so at least some of you know what it means, right? So in Android, debugging is supported by several different tools that are available to you. One of the main components of Android debugging is called as ADB, or the Android Debugger, ADB. When you start up Eclipse and start up your Android device, ADB is automatically started and provides the connection between Eclipse and the emulator. And it acts as the middleman between the device and your development system. If you hook up a real device using a USB and then you are carrying out tests on the real device, ADB allows you to access the real device from a shell and then carry out tests. The second part is the ddms, Dalvik Debug Monitor Server, ddms. In Eclipse, there is something called the ddms perspective, which you can invoke on Eclipse. I think last time I showed you how we can make use of this in practice. So ddms is a graphical program that communicates with your devices through ADB. So ddms basically relies on ADB to provide the actual connectivity. ADB allows you to do things like transferring files to and from the device, running a unit shell on the device or the emulator, and many ways of communicating with these devices and so on. So ddms makes use of the features provided by ADB. And finally, you have the actual device or the Android virtual device. This is the emulator that you use for carrying out testing. So this allows you to carry out environment provides the environment for your application to run and get and be debugged. Okay. Now, when you start up, when you hook up your device to Android, when you hook up your device to your development platform, computer using USB, and you allow USB debugging on the device, then ADB a version of ADP device daemon will start running on the device. If you start an emulator, the ADP daemon will automatically start up in the emulator, and that is what allows you to communicate between the emulator and Eclipse in order to display things on the screen. So with debugging in Android, you have something called the JDWP debugger. I don't know what JDWP stands for. It's some kind of an acronym for debugging protocol that is used for carrying out debugging on different kinds of devices. And so this is also supported by Android and by Eclipse. So using JDWP, you can control multiple devices from your, for example, from the Eclipse environment. Turn on the ddms perspective on your Eclipse in order to get access to these, and then you'll be able to watch several different devices and then carry out debugging on multiple of these devices. So the way it works is like this. ddms is the perspective that you see in your Android, in your Eclipse, and through the ADP, which is running on the host, this ADP on the host is connecting to the ADP that is running on the actual device, whether it is an emulator or the real device. So for a real device, the connection is through the USB. For the emulator, it is a direct connection because the emulator is running on the same computer as your device. Through these daemons, you can have access to all the VMs that are running on your device or on your emulator. Each VM supports a different application, right? In Android, as you recall from the very first chapter, every application runs in its own VM, in its own Dalvik virtual machine. Now, how do you carry out debugging on Android devices? You can dump the stack trace. So, for example, you can obtain the stack dump from the emulator. You can log in with the ADB shell and then get the stack trace. Suppose an application is misbehaving, you can kill the application and then get the stack trace to check and see what is being called. And you can display useful information onto the emulator screen, display things like CPU usage and so on. Get application and system state information from the emulator through ADB shell. You can test for wireless connectivity information from the ddms and so on. Log trace, you saw the Logcat where you can get information. You can log the radio data if you have radio access to the telephony world available on your device. You can get information there. Similarly, you can capture screenshots. Now, if you are wondering, like for example, when you're writing the project report for your course project, if you need screenshots from your device, this is how you can get screenshots from your emulator or your device to include in your reports. You can do screen capturing and so on. And also provides debugging helper classes like util-log and debug, which allow you to debug a lot of information from your Android device. Now, obviously, almost all of you are carrying out development of your Android applications using Eclipse. With Eclipse comes equipped with Adt Plugin, and this is what allows you to carry out debugging. So if you're developing in Eclipse, you would have to install the Adt Plugin, or this is already installed for you. Then you can use the built-in Java debugger along with ddms to debug your applications, doing things like setting up breakpoints, watching variables. All these things are very much supported from Eclipse. If you're familiar with Eclipse, you would know how to make use of many of these things. Not very difficult to learn, pretty straightforward in practice. So from the debug perspective, as I told you, in Eclipse, you can select the debug perspective by clicking on the ddms on the right-hand corner of your Eclipse window. I showed it to you last time how you can get access to the emulator control, device, and other things, file explorer, and so on. So from the debug perspective, you can do debugging, you can watch variables, you can set up breakpoints for both variable, watching the changes in the values of variables, breakpoints to stop your application at different points, and then check the current state of your application. You can also make use of Logcat. Logcat is your friendly tool. It is one of the windows that is displayed. If your application crashes, usually a lot of information is printed out on the Logcat. That is where you go to check what is going on with your application. Sometimes even simple things like not declaring the correct permissions in your manifest file will cause you problems. And again, let me tell you, sometimes even those simple things will annoy you for hours together before you discover. Please make use of the Logcat to check if your application crashes. Check the Logcat to see, especially on the Logcat, you have things that are highlighted in red color. Check and see what they are saying, and it's a very good way of getting information out of your application. So the DDMS perspective in Eclipse, it allows you to access many things. It allows you to access the different devices, emulator control. We saw the use of emulator control already in one of the previous cases where we used emulator control to set the GPS coordinates for our device. Logcat, I have already mentioned. You have another window called threads that you can open in order to watch all the currently running threads on your application. Heap allows you to see how much heap usage is taking place in your application. Especially if you're suspecting your application is having some kind of memory leak, this is definitely a good place to check, together with allocation tracker. File Explorer, we already saw the use of File Explorer in some of the labs where you have to transfer files to and from the device. We have seen how to make use of it. So to access the DDMS perspective, simply either look to the right edge of your Eclipse window, and then you will see those perspectives there. Alternatively, on the menu bar, go to Windows, open Perspective DDMS, and that's how you open the DDMS perspective on your device. Okay? Now, what exactly does DDMS provide? It provides port forwarding services, screen capturing on the device, thread and heap information on the device, Logcat, radio state information, incoming call, and SPS spoofing. So for example, if you are seeing, like when your application is running, suppose the user suddenly receives a phone call, will your application save state and pause correctly or not? You can easily cause a mock phone call to be generated to your Android emulator, or even to your real device that is hooked to your development platform, by using the emulator control window that is available in the DDMS perspective. Location data spoofing, we saw how you can deliver the latitude and longitude information to your device or to your emulator using emulator control. Now, DDMS is already integrated into Eclipse. If you want to invoke DDMS as a standalone, go to the tools directory of your SDK, and it should be available there for you. So you can either invoke DDMS through Eclipse, or you can invoke a standalone version of DDMS explicitly in order to check for these things. Okay? So these things are going to be your close friends over the next few weeks when you are developing applications for your project. Especially right the day before the demo, you see your application crashing, go to DDMS and then make use of all the tools to track down things. You have experience with DDMS? Yeah, see, very, very useful in practice. Okay. Now, as you recall, in Android, every application runs in its own process. This is the first thing that I mentioned in the very first introduction to Android. and which runs in its own virtual machine. Every application gets its own Dalvik virtual machine. So that's why all applications are sandboxed in Android. So every VM exposes a unique port that the debugger can attach to. So when you start DDMS, it connects to ADB, and from there, whenever a device is connected, the VM monitoring service is created between the ADB and DDMS, which is what allows you to track things going on the virtual machine. And once the VM is running, the DDMS and the VM process will be able to retrieve all this information for you. I'll demonstrate this by starting Eclipse and then showing you how the DDMS perspective works in practice. So by using DDMS, you can connect to different devices and then be able to view things that are going on each of these devices. Things like, for example, heap usage, tracking memory allocations, working with an emulator or device's file system, thread information, spoofing, Logcat, and so on. I'll show you how each of these things work in practice. Log is yet another way that you can very usefully track information. Logging is something that you should definitely make use of. Log.t and log.t. These are all classes that you should definitely make use of within your code in order to print things out. Especially when you're debugging on your device, you really, like when you debug in using standard computer, you're able to see things being printed on the console. For a device, you don't have that, so that is allowed by using the Logcat. You can declare from the logging class, you can declare a lot of information to be displayed. So within your code, you can include something like this within your code, and that allows you to print things onto the screen and then watch things being printed on the screen. Let me show you some of the DDMS perspective on the screen in Eclipse so that you will see how this is actually made use of in practice. So for that, let me start up Eclipse. We'll start up a couple of emulators, and then we'll see what the DDMS perspective looks like in Eclipse. Okay, as soon as Eclipse starts here, I'll bring it up onto the screen. Okay, here we go. So this is Eclipse. Let me see. Seems to be a bit slow today. Just give it a minute. Sticking to the screen. Okay, where exactly is this DDMS perspective? If you go to the right-hand corner of your Eclipse window, I think it looks pretty much similar even on Android. If you click on that arrow there, you would see this perspective called as the DDMS perspective. You can start the DDMS perspective and you will be able to see a lot of those features there. I mentioned about emulator control. We saw heap, console, allocation tracker there. You can start up, this is Logcat. Then you have, this is File Explorer. If you have a device, this is devices. Now, let me start up an emulator, and then you should be able to. It's not the emulator starter. Let me see. That is the AVD starter. So if you start up an AVD, for example, let me see. That AVD will automatically show up on the screen in the devices there. So you saw that previously this is empty, now the emulator is up, but as soon as the emulator starts up, it should be able to allow you to access inside the emulator and then be able to watch a lot of things going on in the emulator. Let me switch back to the Java perspective so that I can start an application. Get rid of the JUnit. Let me start an application. Let's see. As soon as the emulator is ready, just give me 1 minute for the emulator to get ready, and then I'll bring it up there and we'll start this simple application. Okay. So I have the emulator running now. So what I'm going to do is to bring the emulator onto the screen here temporarily, and then we'll run this application, and then we'll switch to the ddms perspective. Let's see. The application is running. Now, if I switch to the ddms perspective, I should be able to see the application running emulator control. If I click on devices, it lists all the different processes that are running on the device. So let me select a particular process, and I would say start tracking, and then it will start tracking that particular application. And as the application is running, for example, I click on something there, and then I'll be able to go back to the ddms perspective and then say get allocations, and then I should be able to see all the different allocations that are taking place on the screen. I should be able to see that heap is not enabled for this particular client. I can control, say for example, using File Explorer, I will be able to see what are all the things that are put on this particular system. So I can go to the ASD card and actually put a few things there that I might have done before. So File Explorer, Logcat. Again, Logcat is a place where you would see information being displayed on the screen. By using Logcat, every time you do something on your emulator, things are printed onto the Logcat. So if I click on something like this, again you will see additional information being printed on your Logcat. So this is one place where you can go and check for what is going on there, and you can check each one of them and then see what is going on. So this is Logcat being printed on the screen there. If there is any problem within your application, in this particular case, this application runs correctly, so I can't cause any problems for this application. I can only do a few things here and there. I should be able to see things being printed on the screen as things are being accessed. I'll be able to get a lot of information about each and every one of them by parsing them to see. If your application crashes, you will see a bunch of red lines coming here. Some of these are just warnings that are coming up, or errors that might have been experienced that you can check. So you see, if you see something in red, that means that something is going wrong in your application that you should be paying attention to, and so on. So if your application is crashing, check the Logcat to see what is going on your application. So that is one way where you can easily get a lot of information about your running applications. Now, if you want to control different devices, you can invoke this. So if you have two devices, two emulators that are started, so right now I have only one emulator that is running, I can start a second emulator and I'll be able to see, you'll be able to see that both of them will come up on the screen. So if I start a second emulator will start running, and then I should see a second thing popping up on the screen here. So this is the second emulator. Suppose I want to direct my queries from this emulator to this emulator, I can simply switch, and then and then whatever you do from ADB and so on will be directed to this emulator of that client. So you can track on the different emulators. So all these kinds of features are available within Android. So please do make use of this DDMS perspective effectively while you're writing your applications to get a lot of information about your applications. Okay, so getting back to the application. Close the emulators. So that sort of gives you a complete overview of the different kinds of features that are available within Eclipse for carrying out debugging